Here's my question for you. Are these functions? It's a yes or no question. Are these functions? Lydia, what do you think?
Yes.
That's a great guess. It's not right. What is the difference between these equations and functions? What have you seen for every single function, including the ones on your test, that you've gotten? So you have your tests back in front of you. Take a look at your tests. What is different between the function and these equations? It has f of x. F of x takes the place of y. Very good. Okay? So they're very similar to functions, except these are linear equations. How do I know they're linear equations? Well, there's the equal sign. It's linear because my x isn't squared, cubed, anything like that. It's just got an exponent of 1. So it's going to be a linear equation, which means it's a straight line. I am going to, and I wish Mrs. Armstrong was still here, because I used this analogy in second hour. Who's ever heard the analogy, prime the pump? What that means is it's an old-timey thing that to get water, you used to have to pump water out of a well. And you had to prime that pump by really getting it going, and then the water starting to flow. I'm too young for that. But I'm not naming names who wasn't too young for that. Just saying. Somebody knows what priming the pump is. So I'm going to prime your brains for the lesson. What's funny, Reagan?
Nothing.
Don't worry, I'll let her know when she comes back. So, here's our five x values that we're going to substitute in. Oscar, heads up. Oh, cut the corner. Throw that away, please. Thank you. So when I substitute in 2, 2 times 2 is 4. 4 plus 1 is 5. 2 times 1 is 2. 2 plus 1 is 3. 2 times 0 is 0. Plus 1 is 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. And negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Does everybody agree there? Okay. Here's what we're going to do. We're going to start with our smallest numbers and go up. How do I get from negative 2 to negative 1? What did we have to do to get to negative 2 to negative 1? This should be a simple thing. How do we go from negative 2 to negative 1? Add 1, that's it. We added 1. How about from negative 1 to 0? Add 1. 0 to 1? 1 to 2. So those numbers stayed constant. What I mean by constant is they stayed the same. We were adding 1 to each x value. Does everybody agree? So again, we start with our smallest number. How did I go from negative 3 to negative 1? Add 2. How about from negative 1 to positive 1? Add 2. Add 2. Add 2. So these stayed constant, these stayed constant. Does everybody agree? Okay, let's graph. 1, 2, 1, 2, 3, 4, 5. 2 up 5. 1 up 3. 0 up 1. Negative 1, negative 1. Negative 2, negative 3. Why does this graph have arrowheads on the end?
Because it keeps going.
Why does it keep going? You're absolutely right, it keeps going. Emma?
Because it represents all possible solutions.
It represents all possible solutions because this equation is everywhere that line's going. Okay? So, we're going to come back to this. So again, negative 2, negative 1, 0, 1, 2. The only difference between this equation and this equation was that negative sign. Negative 2 times negative 2 is 4, plus 1 is 5. Negative 1 times negative 2 is positive 2, plus 1 is 3. 0 times negative 2 is 0, plus 1 is 1. Negative 2 plus 1 is negative 1. Negative 4 plus 1 is negative 3. Negative 2 to negative 1, how do we get there? Add 1. Negative 1 to 0. 0 to 1. 1 to 2. Okay, so since we started with our smallest, we still stay up there. How do we go from 5 to 3?
Subtract 2.
Subtract 2. 3 to 1?
Subtract 2.
1 to negative 1, negative 1 to negative 3. So the only difference, they're staying constant still, but the only difference is here we added 2, here we subtracted 2. Let's see what happens. 1, 2, 1, 2, 3, 4, 5. Then negative 1, positive 3. 0, 1, negative 1, or 1, negative 1, and 2. So here's what I want you to do. Talk it over with the people around you and tell me what differences do you see in the graphs versus the lines, and why do you think they ended up the way that they did? So what's happening differently in the graphs? Why do you think it's ending up that way? And try to find a reason why. So I physically want you talking to the people around you.
I don't know why, but the first one is going from right to left, and the second one is going from left to right.
Because on that one, you're adding to the second.
Yeah.
It's the same function. That's the same.
Yeah, okay.
How do you not get that? I don't get how that.
Because that's -2 and that's positive 3. Yeah, that's right.
Yeah.
You did it correctly, you just have to change the X is different.
Explain to me how the
Okay. Mr. Wasson, you're amazing, dude. Tell me, why do you think, or first off, what's different? Just tell me about what's different.
Well, it's different. It's different with like the ways adding 2 ones.
Yeah, so these were adding to, these were subtracting to. Good. What changed in the lines? So this one was adding to, that one was subtracting to. What changed?
The -2.
What about the line? Just the line itself. Do they look exactly the same? No? What does this one appear to be doing?
It's going it's vertical.
Yeah, it's going up, right? What about this one? From left to right, it's going what?
Going up
So from left to right, it's going which direction?
down.
Oh, down. So one of them's going up, one of them's going down. Why do we think one would be going uphill, one would be going downhill? What's the key in there? Madison?
On that one, you're adding, on this one, you're subtracting.
Oh, so this one's a positive, and this one's negative. Is that what you're saying? That's very good. What about in the actual equations? Is there something in the equation that kind of helps me see what's going to be positive and what's going to be negative? Ava?
There's a -2.
So I have -2 here, and the line's going downhill. This is +2, and it's going uphill. But they're both positive ones. Does that do anything to it? Well, let's see. Wait a minute. This one has 0, 1. This one has 0, 1. Where are they both crossing that graph at? Where are they both crossing at? Curtis?
The 1.
On which axis? The Y or the X?
Why?
Oh. I bet that's important later on. I bet that's important. So we can see that these are constant. We can see that if it's adding, it's going uphill. If it's subtracting, it's going downhill. Go ahead and get out your notes or a fresh piece of notebook paper, because we are starting a new unit. So this unit is extremely, extremely long. I mean, it's extremely long. And they say it's called Unit 4. And put all of this stuff in Unit 4. I'm not going to do that. So we're going to have a Unit 4, and then we're going to have a Unit 4, we'll call it B. And what did I call it earlier? I think it was banana fish. Like, it doesn't matter what the second part is. It's still part of Unit 4, but it's not really the whole thing. So first, we are in Unit 4. We are graphing linear equations. And this is day 1.
Thank you.
So we are graphing linear equations.
That's good.
I feel like if we're able to stay awake and listen, that this unit isn't too hard. Your first quiz, which will be sometime next week, shouldn't be hard. It's just going to be with this first word. And the first word is all about slope. I student taught, where I went to college was in Pennsylvania. It was up towards Erie, which is more mountainous. But all of my kiddos in Pennsylvania, when I say, what word reminds you of slope? Every single hand went up because they all did this. And then I moved to Virginia, which they didn't do so much. And then I moved out here and nobody does this. I was an avid skier. Where we lived, we were in the mountains. We skied almost every weekend. So these kids all raised their hands and said, slope is like a ski slope. And I'm like, yeah. And where we ski and where everybody skis, there's usually 3 different distinctions. There's a green circle for beginner. There's a blue square for intermediate. And then there's a black diamond for advanced. Then they have double black diamonds and so on. Now, my buddy Nick and I know it's strange that we're both Nicks, but my buddy Nick and I used to have season passes to go skiing. And I'm a pretty proficient skier. I'm still a good skier. My knee hurts me when I do it. But we didn't start off like that. We started off on those green circles doing like the wedge skiing, where your feet are like this, and you've got the ski poles, and you push, and you go, and then you fall sideways. But you go real slow, and you're kind of going, hit. So the first ski slope is like this. It's not very steep. It's almost flat. It's like you're pushing yourself to get going. Then you get to those blue squares, which are the intermediates. And you might get like some moguls, which are little bumps in the snow. But intermediate, okay, now you're going down a little bit. You've got some more curves. Well, eventually my buddy and I got pretty good, and we did what was called parallel skiing. Parallel skiing is your feet are together, and you're able to, and your skis don't really move. They stay right next to each other, okay? We started going down the black diamonds. And the black diamonds are the most advanced. Well, we lived in Pennsylvania. We skied in New York. Our senior year, we wanted to go to Colorado. That was going to be our senior trip. So my buddy Nick and I and a couple other friends were like, we're going to rent a cabin up in Aspen, and we want to ski in Colorado. And we did. So we got out there, and my parents had a little bit of money, and they're like, okay, great, you're going, you're going to get a guide. Yeah, no problem. So we got this guide. This guy was one of the coaches for the ski resort. He's like, does everybody know how to ski? Now, we came in with skis. Yeah, we know how to ski. Are you guys good skiers? Yeah, we're 17, 18-year-olds. Of course we're good. Yeah, we're really good, because my ego has gone down since then, obviously, as you can tell. But yeah, I was very ego-driven. Yeah, I'm a fantastic skier, guy. He's like, well, listen, have you ever been to Colorado? No, man, we ski. Where have you skied? Well, Pennsylvania, West Virginia, New York. He's like, okay, the ski slopes out here are not the same, but don't worry about it. We're going to be fine. He's like, no, guys, really? We're like, stop. We're going to be fine. It's like, okay, I'll see you at the bottom of the hill. Don't get hurt. No problem. So we ride the ski lift, we get up top. And again, Nick and I are the better of our skiers. Our buddies leave, and I'm the dumb one. Like, Nick was the one who followed me. Like, Nick and I played basketball almost every weekend during the summers. I was the one that protected him. He was the friend who would say things and then run behind me because I'm so big and scary, you know what I mean? Like, I'm fighting guys safely by using words. Saying, don't say that on a basketball court because of Nick. I'd never fought. So, we're up at the top of this ski slope, and Nick's like, we're going to go down this black diamond. Well, yeah. So we get up there. Okay? I'm going to borrow this. So, here's my skis, right? And we're getting up to this ski slope, and we're skiing. Okay, we get to the top of the ski slope, and it does this. And my skis are just hovering over nothing. And I stop. And I'm not scared of a lot of things. I'm scared of heights. Like, I don't like being on the ski lift. I like skiing, but I don't like being on the lift. We got up, and I did one of these. Because, I mean, it's not straight down because that'd be stupid. But it's down. I mean, Nick goes, what's going on? I said, you should come up here and see this. He goes, no. I said, no, come on, Nick. You should come and see this. He goes, no, you just go. I'll follow you. Being the dumb guy that I am, I'm like, yeah, I'm going to go. And I kind of, and I stopped. He's like, what's happened? I was like, I can't go down. He's like, yeah, you can. So he skis up behind me and pushes me. And I made it about 4.3 seconds of utter screaming and utter terror. Again, I'm a good skier, and I couldn't control myself. It went straight down, and I tried to turn, and the next thing I know is my skis are that direction, my poles are that direction, and Nick's at the top of the hill screaming, like laughing. Finally, he stops. He's like, you all right? My legs are up in the air. No, I'm not all right. I just made a fool of myself in front of the girls that we were trying to impress who went past the black diamond because they're not dumb. There was a reason why the guy said, hey, the slopes aren't the same. No, that black diamond was the scariest thing that I've ever been on. Like it was literally, you put your skis over and you fall. But I digress. Slope is really like ski slopes. Oscar's like, I can't believe he just talked like that. Oscar, are you tired? Are you awake?
Yeah.
Are you happy?
Yes. Yeah.
Oscar, I got you a gift while you were gone.
No.
I'd like you to have it. Thank you. You're welcome. No, I'd like you to keep it forever.
Oh yeah.
Okay, forever.
Yeah.
Okay. So, slopes. Slopes are just like ski slopes. What's happening with them? Well, there's different levels of slope. Mathematically, slope is the steepness of a graph. And when I say a graph, what do we mean by a graph? Because it's not just a graph. What are we actually graphing? Think about what we just did in our warm-up. What are we actually graphing? Oh, it's going to be an equation. So it's the steepness of the equation. And by steepness, it can go downhill, it can go uphill. It can go really, really, really uphill, it can go really, really downhill, or it can be almost flat. Okay? So slope is the steepness of the graph. Slope is a constant named, and then this is one of the stupid things in math. They've decided to name a variable slope. What would make common sense for a variable to be for slope? What should we name that variable for slope? What letter should we use? S. That seems smart, right? Well, mathematicians said, no. That's dumb. And they didn't use S. So let's take another wild guess. What do we think would be a good letter for slope?
L.
L. No, that is not even close. And you know why it's not close? Because it's dumb. They said, hey, slope will be called M. Because that makes perfectly good sense to us. And I had a question earlier in their class. They said, well, why? And I said, that's a great question. And then I turned around and ignored it because I don't know. I have no idea why mathematicians said, you know what? M's the right choice. That's what we should do. We're going to call slope M. I don't know. But the key here is slope is a constant. Once we know the slope of a graph or of the equation, it stays the same. It's not going to go like this and then change. It stays the same for my graph. Everybody with me? For us to start, slope must be a fraction. Slope must be a fraction. All right, I'm changing the notes a little. No, sorry. Okay? And I'll explain all of this in a second. There are 4 types of slope. And we've already seen 2 of them. When you get a graph, you can look at the graph and immediately have an idea about the slope. So first, we are going to start with a positive slope. When you look at a graph, a positive slope goes from left to right, uphill. So if it goes from left to right uphill, what's that going to look like? Well, here's my graph. If I start at the left, and I'm pretending that I'm walking up this, I'm walking uphill. I know that my slope has to be positive. Okay? Did we see something like that in the warm-up? We had a positive too. It was going uphill, right? Okay? Then we've got negative slope. What do we think is going to happen in negative slope? Well, I need more than one hand. Michaela. Not going to go right to left. Ellie? Very good. It's going to go left to right. And we always think about reading. We read from left to right. We read from top down, right? So we're going to read left to right, downhill. So now if I've got this graph, if I start at the left side and I start walking along my equation, it goes downhill. I know that that slope is immediately negative. We're going to spend a little bit more time on these two tomorrow. But I was really impressed with my second hour. I said, okay, who thinks they know what a zero slope is? Not expecting a single one of them to get it. And Buddy in my front row raised his hand and said, no, I got this. And he was absolutely correct. What do you think the line's going to do to have a zero slope? Ellie, go straight which way? Very good. It goes horizontally, which means left to right. So if I have a graph, it's going to go directly across. Great job, Ellie. But we've got one more. And then I'm going to give you a second to get caught up because I know there's a lot getting thrown at you. We've got one more. And this is the most misspelled word that I see in algebra, is undefined. I have a lot of people wanting to make it a UFO and call it unidentified. It's undefined. So this slope is undefined. Doesn't get a number, it doesn't get a fraction. It simply gets the word undefined. What do we think is going to happen with this slope? Go ahead, Curtis.
It goes vertically.
Very good.
Just wanna make sure I remember.
Which means up and down. So it goes completely up and down. So just by looking at the graphs, you can tell me a couple different things. You can tell me whether they're positive, whether it's negative, whether it's zero, whether it's undefined. If you do not have those copied down yet, please do so. Now, so far, all we have is, hey, it's going to be positive, hey, it's going to be negative, it's going to be zero, it's going to be undefined. But I told you that slope must be a fraction. Well, today is by far what I think is the easiest way to find slope. We're going to have slope and find slope three different ways. We're going to count, we're going to subtract, and we're going to find a variable. Today is all about counting. And slope is in this form. Rise over run. And you will hear me say rise over run probably 300 times within the next 2 weeks. Rise over run. Rise is on top. Think about it that way. Run, you're running on the ground floor, so it's on the bottom. Rise. Which direction do we think rise goes? Cheyenne. Up. Rise goes up. But it can also go down. So rise is both up and down. Run, which directions do you think run's going to go, Brock? Which directions? If rise goes up and down, which way is run going to go?
Up.
Rise goes both up and down. So what do you think run's going to do? What are our other two directions? If it's not up and down?
Horizontal.
Yeah, left and right. Very good. Okay, going to keep asking some questions here. So on this graph, I've got my y, I've got my x. Which letter is my rise? If we're going up and down, which letter?
Y.
Very good. The rise are my y values. Which means my runs are my x values. I am going to show you just one way to do it today. Do you have to do this way? Nope. But it will be my way to try to get you to understand it to start. So the question would say, find slope. And this is what we'll be doing for the rest of the class, is finding slope. So I will have a graph. And it will be easier once you have graph paper that's already given to you. So here's my graph. The first thing that we're going to do immediately is say, okay, if we're finding slope, we're going to say m equals, and then put a fraction bar. Why? Because we know that it has to be a fraction. Just by looking at it, is it positive, negative, 0, or undefined? Emily? Positive. Why? Yeah, from left to right, it's going uphill. So it's positive. So I don't need to put a negative at all with this. So here's our first step. We always start at the farthest left point. So here's a point. I'm starting here. I'm going to make a triangle. And then I'm going to put a little man at the farthest left point because he needs to climb that triangle. Do you have to put the little man? No. But this is the way that I like to think about it. This little man has to climb up my triangle. How many places from this point does he need to climb up? Maddie or Madison? Well, let's see. If he climbs up one, boop, he gets to that one. So he has to climb up 2 places. Is that my rise or my run? Did we go up and down or left and right? So that was my rise. So that number has to go in the numerator. So now my little man's up here. Now he has to run to that next point. Notice what I'm going to do here. It's, again, going to be easier on graph paper because you're going to have these all gridded. But there's a point, there's a point. How many places does he have to run over? Well, let's see. He runs to this line, then he runs to this line. So he has to run 2 places. So is this my slope? Nope. What's wrong with 2 over 2? Ellie?
I forgot what it's called, but they're the same.
Go ahead, Nicholas.
It's a hole.
Okay, not
So-
quite. Go ahead, what were you going to say?
So it needs to be 2.
No? What needs to be done with this? Maverick?
It needs to be a 1.
Okay, why? What do we need to do to 2 over 2? We need to simplify it. We can divide both by 2's. That gives me m equals 1 over 1. What does that mean? That means from any point, if I go up 1 and over 1, that's on my graph. Up 1 over 1. Up 1 over 1. Those are always going to be on my graph because slope is constant. It stays the same. It goes up 1 over 1, up 1 over 1, up 1 over 1. That's importante. And if you're like, man, that's confusing, okay, it's allowed to be confusing to start. it will probably be confusing the rest of the day. But hopefully tomorrow it's going to start getting a little bit easier. Okay, so here's number 2. Still finding slope. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Go ahead and get it copied down. What's my first step to find slope? What should we do right now? What should we draw first? Emma. Okay, so we can say m equals. We know it's going to be a fraction. Looking at this graph, positive, negative, 0, or undefined. Ryan, what do you think? Am I looking for, is it going to be a positive slope, a negative slope, undefined, or 0? So go back to those notes. What do you think this is going to be and why? Why? Oh, it's going downhill. Does it matter where I put the negative? I could put it at the top, I could put it at the bottom, I could put it right out in front. I'm a right out in front kind of guy. But don't put a negative in the top and the bottom, because then that would make it positive. Then we have to draw a triangle. And I'm going to say my favorite mistake. During second hour, we drew a triangle anywhere we wanted. That's fine. I will always try to draw my triangle up and down first. So I go to my left point. Can I go up from my left point to go to my another point? No, so I have to go down. Then I go to my right. If you go to the other side and you go over and then down, is that fine? Yeah, I'm going to show you how to do that one too. But I always try to draw my triangle up and down first. Okay, the ones are different colors. Here we go. So here's my guy. He starts off at the left point, or the farthest left point. He has to go down. He has to go down 1. He climbs down another 2, 3, 4. So the slope is negative 4 over something. Are we done there? What does he have to do now? So he's made it down here. What does he have to do? He's already risen. He has to run. So now he's going to run to this line 1, to this point 2. Am I done with negative 4 over 2? Go ahead. What do I need to do? Okay, by what?
2.
So I can divide both by 2. That gives me m equals, don't forget your negative, 2 over 1. Which means I could go down another 1, 2 over 1. And if my graph was perfect, it'd be on that line. Let's see, down 1, 2 over 1. Oh man, there it is right there. Down 1, 2 over 1. It's right there on that line. It's amazing. Okay, so I want you to talk it over with each other. I want to see if you guys can get this one on your own. 1, 2, 1, 2, 1, 2, 1, 2. So you are finding the slope of this line. Finding the slope of this line. Go ahead. I'm going to give you a little bit more time, but I want to start with this part. So we have m equals. It will be a fraction. You need to be able to look at this and say positive, negative, 0, or undefined. Mariah, is this graph positive, negative, 0, or undefined? Look at your notes if you need to. Why?
Because it is,
What does it say for negative?
it's downhill.
From left to right, it goes downhill. So we know it's going to be a negative fraction. Go ahead, keep on going.
Just put them at the, yeah, put them at the, yeah. So.
What'd you get?
I didn't know what the yours is. That's what I was saying. She's not gonna-
Did you draw it, Melissa?
Well, I was trying to fit it.
Okay,
Can you reduce it?
So,
Can you simplify that?
I drew the triangle the opposite direction of what I told you to do. Can we still do it this way? Absolutely. My guy this way with the red, purple triangle that I drew, what does he have to do first? Rise or run?
Run.
He has to run. He's going to run 1, 2, 3 spots. Where does run go? It always goes in which spot? The numerator or denominator? Say it again, Cody. Denominator. So now he's here. Now he has to rise, which is up and down. He goes down 1 line, 2 lines, 3 lines, 4 lines. That's it. Negative 4/3. Mr. H, what if I drew the triangle this way? Would it work the same way? Well, let's see. Down to this line. 2, 3, 4 over 1, over 2, over... Oh my gosh, it's the same thing. Amazing.
And I am going to point something out. It's just one of the things that I kind of noticed when I was walking around. Each of these kind of bubble things that Mr. H is drawing, that is where you see the next step on the graph, okay? So this is how he's getting 1, 2, 3, and then 4 is why he's drawing these intervals.
Yeah.
Okay, so that is just to help you count and make sure that you know what points you're going to.
Yeah, you don't need to make them, but I would highly suggest putting as much work on there so you can see it as well.
Yeah, it's helpful.
Okay, last one. Last one for the day.
We draw it and not the flip it yet.
1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3.
Fast if it's taking and I'm gonna draw it big so that we can see it, okay?
So we're finding slope.
What do you mean by an interval?
How much we're counting by.
Okay, thank you.
You're welcome.
Point here. And then we're gonna go to 3 and I'm going to point here. And then we're gonna connect it, and that's just what he drew, right? So the first step is that we're gonna put n equals another fraction mark. Now, the next step is we're going to look at the form and we're going to see whether it's positive slope or negative slope or zero slope or not. Just by the way the lines go. From left to right. So we know that the sign and the slope is going to be positive. So we're going to, isn't that the proper fraction? Is it 2?
That's your fraction.
That is showing the different colors.
Okay, Oscar, taking a look. Positive or negative? Let's just, how do you know it's positive? Because it's going uphill. Let's just start there. So we know it's got to be a fraction. We know it's positive. I personally would draw my triangle from my left dot going up and down first, and then to the other point. Go ahead, keep finding it.
I'm gonna draw a girl because. So we gotta get this girl from here to here. And from here to here. If we go from here to here, is that the right or the wrong? The right, okay.
Okay, Reagan, what'd you end up with?
Places these.
Three on top and two on top.
So 3 over 2. So my slope should be 3 over 2.
What number do you
Let's double check her. So we start at the left point. My little man's right here. He climbs up to the first rung of the ladder. Second, third. There's my rise of 3. Now he's running. He hops to one board, hops to the second board. That's how we get our 3 over 2. We will be spending a lot of time with this. Are there questions today? Tomorrow we'll practice.